Imagine being able to control a computer just by thinking. No mouse, no keyboard, just pure intention turning into action. It sounds like science fiction, but it's already happening today. And it's opening the door to something even more profound. A future where our brains can interface directly with AI computers. Welcome to Axicode. Today, we're exploring brain-AI interfaces, what they are, how they work, and how they could completely reshape the way humans think, communicate, and remember. We'll start with what's possible right now. Then look at the major players pushing the boundaries, and finally explore what this might mean for human potential in the decades ahead. So let's begin with the part that's real, not hypothetical. Right now, brain-computer interfaces, or BCIs, are giving people with paralysis the ability to move cursors, type messages, and interact with digital worlds using only their thoughts. These systems read neural activity through either implanted electrodes or non-invasive sensors, and ultimately decode patterns linked to intention and translate them into commands. In 2024, a paralyzed man named Nolan Arbaugh became the first human to receive Neuralink's implant. Within weeks, he was using it to play online chess, browse the internet, and control a computer purely with thought. Neuralink's chip sits inside the skull, with thousands of tiny threads listening to neural firing in the motor cortex. When Nolan thinks about moving his hand or shifting a cursor, the implant picks up those signals and sends them wirelessly to a computer that decodes his intent. But Neuralink isn't alone. Synchron, another BCI company, uses a radically different approach. Instead of brain surgery, they insert a tiny electrode array through a blood vessel, like a stent, and guide it to the motor cortex. This stentrode has already enabled paralyzed patients to send texts and emails using their thoughts. It's less invasive, and while it captures fewer signals than Neuralink's implant, it shows how many different paths this technology can take. Then there's Kernel, which is focused on non-invasive BCI. Using advanced neural imaging, their Flow headset uses near-infrared light and EEG to measure brain activity at high resolution. It's not designed for thought-based control, but instead for analyzing cognitive states, focus, memory, stress, and eventually enhancing them. Kernel's work hints at a future where brain interfaces aren't just medical devices, but consumer tools. So that's where we are today. BCI is restoring function, decoding intention, and helping people regain independence. But where this gets even more interesting is where we're headed next. In the next segment, we'll explore what happens when brain interfaces evolve from medical devices into enhancement tools for anyone. As BCIs become more capable, the line between restoring ability and augmenting ability starts to blur. The first major frontier is cognitive enhancement, not replacing the brain, but boosting what it can already do. Imagine memory systems that work like an external hard drive, or real-time access to information as seamless as recalling a personal experience. There are already early signs of this. At University of Southern California, researchers are testing a memory prosthesis for the hippocampus, the part of the brain responsible for forming new memories. In clinical trials, epilepsy patients with implanted electrodes receive targeted stimulation designed by computational models of their own neural activity. The results? Some patients showed memory improvements of up to 50%. It's still early, but it's real, and it shows that enhancement isn't science fiction. Another area of rapid progress is neural decoding, the ability to translate brain signals into speech, imagery, or emotion. In labs today, AI models can reconstruct rough images from fMRI scans and decode imagined speech into text. Right now, these systems require bulky equipment. But as sensors shrink and models improve, these capabilities could migrate into wearable or implantable interfaces. That brings us to a bigger question. In the future, will we need to consciously prompt AI with thoughts, the same way we type into ChatGPT? Or will AI become integrated so deeply that recalling information feels as natural as remembering something you learned years ago? Both scenarios are possible. The first is like having instant access to the entire internet inside your mind, but still needing to intentionally request information, the way you look up something on your phone. The second is more profound. Information feels embedded, like part of your own memory network. You wouldn't search for knowledge, it would surface automatically when needed. Of course, enhancement isn't the only direction. Another emerging field is memory editing. Not erasing memories, that's not possible today, but altering the emotional weight attached to them. For example, Reconsolidation therapy weakens traumatic memories by guiding patients to recall them while under propranolol, a drug that blocks the emotional resaving of the memory. It's already showing promise for patients with PTSD. Now, imagine combining therapies like that with precision neural stimulation or with AI systems that understand how memories form and change. Suddenly, the idea of upgrading or modifying memory doesn't seem as distant as it once did. But with more capability comes more risk and more ethical questions. That's where we turn next. If brain-AI interfaces keep advancing, we'll face choices no generation has ever faced before. What does it mean to have a brain that can be digitally augmented? Who controls the interface, the user, the company, or the algorithm? And how do we preserve privacy when the thing being measured isn't your browsing history, but your thoughts? The first frontier is data. Neural signals are intensely personal, far more revealing than anything you type or say. As BCIs evolve, society will need strict protections to ensure this data can't be misused. Think of it as neural privacy, a new category as important as cybersecurity or medical confidentiality. Another frontier is inequality. If enhancement becomes possible, boosting memory, improving focus, accelerating learning, who gets access? If only a wealthy minority can enhance their cognitive abilities, that could widen social and economic gaps dramatically. It's the same concern we see in genetics and AI, but applied directly to the mind. And then there's identity. If an AI system can help you think, remember, create, or communicate, where does the line blur between you and the machine? Some researchers argue that an AI assistant integrated through a BCI becomes part of your cognitive architecture, not separate from you, but an extension of your mind. Others see danger, dependency, manipulation, even the loss of authentic thought. But here's the hopeful side. Brain-AI interfaces also offer solutions to problems that were previously unsolvable. They can restore speech, mobility, and independence. They can help millions living with neurological disorders. They can give people back the ability to express themselves. And they may even help us understand consciousness in ways we never could before. So, as we move into this next era, the challenge isn't just technological, it's philosophical. What kind of relationship do we want with our technology? Do we want AI to assist us, to augment us, or someday to merge with us? What's clear is this: brain-AI interfaces are no longer a distant concept. They're here, they're evolving fast, and they're going to reshape how we interact with computers, and eventually, how we understand what it means to be human. Thanks for watching Axicode. If you enjoyed this video, subscribe for more explorations at the edge of technology, science, and the future of the human mind.